We invented numbers to count, but now they help us with way more than that. Let's talk types of numbers, starting with our natural numbers, like 1, 2, 3, 4, our counting numbers. They go in this tiny little circle here. When we add in 0 and our negatives, we've now got our integers. So these are all the whole numbers, so including all the natural numbers, plus 0, and all of our negatives. So we have these so we can describe things going backwards, and so we can describe nothing, like 0. Then when we introduce fractions and decimals like a half, third, 5.75 for comparing different sizes of lengths, now we've reached our rational numbers. They're rational because we can express them as one number divided by another. But what about numbers that can't be expressed as one number divided by another, like the square root of 2 or pi? These are useful values that exist and they're the answer to common geometric questions, but they can't be expressed as fractions. So now we're in the world of our real numbers. So this is everything that sits on the number line. But are all numbers on the number line? I mean, logically that would make sense, but sometimes we like to extend our definitions of things. In the maths case, we've invented imaginary numbers. The square root of -1. This is not on the number line, yet it is a number that we can use to solve many equations in physics. And that is when we expand to the complex numbers. Some examples of these: we use I to represent the square root of -1, so we could have 3 plus 2i minus I, and many more. This is how maths grows, by including more and more possibilities. Like thousands of years ago, there was a time where we didn't think that we could have negative numbers or 0, or we thought that everything could be expressed as a rational number. But this is how maths grows, by including more and more possibilities and understanding how they all fit together.